All right, so today we're going to learn about one of the rules of exponents called quotient rule, which is division with exponent. And let's start with this example here. Let's suppose I have like 3. I have like 3 to the 6th power divided by 3 squared, right? Now again, this is the same thing as 3 to the 6th power over 3 squared. That's another sign of another symbol of division, right? Now 3 to 6 powers means we're going to multiply by 3 6 times. We get 3 times 3 times 3 times 3 times 3, right? Times 3. So we got like 6 times there, right? We got 6 times over 3 squared. So 3 times 3 twice, right? And we can simplify 3 with 3 here and 3 with 3. Remember, we can do this only for, when we have multiplication. We cannot do it with addition or subtraction. So what do we have left here? We have like 4 3's here, right? So what we have left is 3 times 3 times 3 times 3, 4 times, which is 3 to the 4th power. 3 to the 4th power. Right? Now we can see the connection between 6, right, and 2 and 4. If we subtract 2 from 6, we're going to get 4, right? So there is a shortcut to this, a shortcut. Right? We get 3 to the 6th power divided by 3 to the 2nd. That will be 3 to the 6th minus 2, which is 3 to the 4th power. So there is a rule to this called the quotient rule, right? So the rule is, if I have, for example, like a to the x over a to the y, right? So we're going to take a to the x minus y. And this is rule. And of course, a got to be different than 0, right? So we don't have to use the long one here, like to multiply like 6 times and divide it by 3 twice. So we're just going to use the rule, right? Let me get you some examples here for the quotient rule. All right, let me get you some examples here. Get some examples here. See, if I get like 10 to the 9th divided by 10 to the 3, right? 10 cubed or 10 to the 3rd power. So again, we're gonna since we have the same base, we're gonna keep the base and we subtract 3 from 9. It's gonna be like 9 minus 3, and the answer would be like 10 to the 6, right? Let me take another example here. I have like 4 to the 9th power divided by 4 to the 8th. Because sometimes we may have like a really big exponent, we can't use like, multiply by 9 times or maybe by 8 times, right? So again, by using, since we have the same base, right? So we're going to keep the base here and we're going to subtract 8 from 9. So 9 minus 8 will be 4 to the 1st power, or just 4. Okay? All right, I got another example here, like 2 to the 4 divided by 2 to the 7. So it's going to be, we're going to keep the same base and we're going to subtract 7 from 4. So 4 minus 7, and that will be 2 to the negative 3. And you're never going to leave your answer as negative exponent. If you want to change this one to positive, you're going to make it like 1 over 2 to the 3rd. And we know that 2 to the 3rd is 8. So the answer is going to be 1 over 8. Let me take another example here. What if we have like 4, have like 5, right, to the 6th power over 5 to 8, right? 5 to the 8th power. So again, we're going to keep the same base. We're going to have like 5 to the 6 minus 8, and that will be 5 to the negative 2. And that will be, when I change this one from negative to positive exponent, it's going to be 1 over 5 squared. and 5 squared is 25.